Hey everybody, just a quick recap here. This is video 3 on our C-15 6NZ twin turbo rebuild. This is out of frame, completely torn down, bare block, and building it all the way back up again. Prior video showed us putting it together to the point where we got the liners in the block. And so now we'll flip over to a video of me putting it together, starting with putting the pistons in the liners. Alright, let's get this started. So here you can see we already assembled the pistons and the liners while we were waiting for the block to get back from the machine shop from being decked. And so I lube up the piston real good, make sure the rings are completely soaked in oil, and all the sides of the liner and skirt and stuff are oiled well. Tighten the compressor down around it. That compressor's got a slight taper to it, so that when you set it down on top of the liner and push down, those rings will just gently compress into the piston and slip down into the liner hole. Then we're prepping the bearings and the rod cap bolts and all that. Some lubricate on the bearings, only on the crank side of the bearing. You make sure that the side of the bearing that goes into the rod or touches the actual rod, that's dry. And then you put some anti-seize on the bolts, stick them down in there, tighten them all up. Obviously I'm not showing all that because camera angles and all that, just it's kind of dull. Here you can see I got the flywheel. I'm prepping it to go in. I'm cleaning out all the bolt holes for the clutch, because there's 12 holes and you only use 8 of them. So 4 of them are going to have a lot of junk in the threads, and if I don't want somebody putting a clutch on there and using dirty thread holes trying to run clutch bolts in. So got it hung on the back of the crank there. It was important to get this flywheel on at this point, because that's, you know, the easiest way to turn the crank over, especially once you get the head on and those cylinders start making compression. It's just not going to roll very easy. So we got the flywheel that we can put a turning tool in the bell housing and turn the engine over. And so after you get your rods in, then it's safe to put your oil squirters in, the piston coolers. You can see right there they're in the block. They go into the oil galley that feeds the rods and mains, and so you got engine oil pressure coming through those into the squirters, shooting oil on the bottom of the pistons, keeping them cool. There I'm knocking out the plugs and putting new plugs in. There's 4 of those. They're for dipstick holes, and so, you know, depending on the configuration, 3 have plugs, 1 has a dipstick. There's the oil pump. The new oil pump doesn't come with the gear on it. You got to switch it over from the old one. The block prepped for the shim gasket and spacer plate to go on. We use that aviation gasket sealant. Caterpillar doesn't necessarily call for it anymore, but they used to, and then they called for it because they're having trouble with oil seeping around that shim gasket from all the oil drains going past that shim gasket. So they called for aviation sealant to help stop that. Then they updated the head gasket, where they had rubber inserts that help the oil drain past that shim gasket. And I mean, it's an improvement, but we still use that aviation sealant around all of the oil drains in the head, because it's just extra insurance. We don't want to see oil seeping past there. And so we put the head gasket down, make sure that it is a good fit, everything is lining up, all the bolt holes, the fire rings, the water grommets, and so yeah, we're just laying all that down a little bit more A little bit more of that aviation sealant on the oil drain funnels that they got in them now. There's a couple plugs in the ends of the heads you can see I'm putting in now for oil passage front to back. You got to put them in before putting the head on because you can't access the one behind the gear case until, or you know, with the head on the engine. It's no fun to forget that. So using a couple long head bolts to line up the head, get those started, and then the head drops down real simple right in place. And so just putting the head bolts in, 26 of them, 10 long, 16 short. So there's a torque sequence to this. You torque each of them to what, 200 I think, and then you go back through the sequence again to 330, and then you go through it one more time to 330. And you'll notice as you torque them, even at 330 the second go around, the bolts in the center of the head, you can turn those a decent amount. As you get to the end of the sequence, the bolts don't turn so much, but it just goes to show that, you know, that head's not fully seated till you've really went through all of them a couple times and got complete pressure on the head, on that head gasket. So that there is the seal for the water pump. Just O-ring seal there. Stick it in, mesh it in with the bowl gear, and there's a couple bolts that you can put in right now to hold it in place. Some of those bolts holding the water pump on, you can't put it on until the bracket for the belts and the idlers and all that, the alternator and AC compressor on. Got that little spacer plate between the manifold and the water pump, and now there's the water pump manifold. You're going to put our cam in. Those little spacers there, screw into the back of the cam. You lube everything up real good, and they guide the cam through the cam bearings so you're not doing damage to the bearings as you install it. I forgot, but you gotta leave those guides just a little loose on the cam, because if you tighten them up too much, they tend to cock just a little, and then they're tight going through the bearings. And so I called Mark over, to be honest. Hey, this cam don't want to go in, and he reminded me, you didn't loosen or you tightened those spacers up too tight. Sure enough, backed them off just a little, and it slid right in. There's a little seal and adapter that runs your cam into the gear case and seals up the oil and everything. So just installing that little deal there. Loctite on all this stuff. And now we're ready for the cam gear. There's a dowel on that cam gear you gotta line up, and then you can feed your 6 bolts in and everything. Then we put the idler gear in temporarily, and the engine's already pinned so it can't turn over. And so we torque all those bolts. Now when I say that the engine's pinned, I mean there is a threaded hole in your flywheel that you can stick a bolt in, and it put the engine on top dead center on number 1 and 6. So basically we already did that, and you do that to hold the engine in place, to torque stuff like we just did, but also that's how you set the timing on this cam gears. You got to have it top dead center on number 1, And then at the very top of the cam gear, you can see there's a little white paint mark up there. There's a timing mark there, and then on the top of the gear case there's a elevated little triangle there, and you got to line that mark on the cam gear up with the elevated triangle on the gear case. So that's what I'm doing there. You can see I'm looking close, make sure it's all lined up. But that idler gear, it's adjustable. You can see me prying on it and moving it, and you gotta, the reason it's adjustable is because you gotta get your backlash between your cam gear and your idler gear correct. It's on an arc where the backlash between the idler and the bull gear is always going to be perfect, but they had to make it adjustable because, like in this case, we had the block decked, and you know, sometimes you have a head that's decked, and so doing that's going to affect the backlash on those gears, so it had to have a place to adjust it. So spec is like 8 thousandths plus or minus 4 or 4.5 thousandths, something like that. And so I keep playing with it till it feels about right, and then I got my dial indicator set up on the gear there, and I'll admit it's not the best setup. There's better adapters to measure backlash on this, but you know, we just don't have what's ideal at the moment, and we get by with this. One of these days when I have time to order some parts, I'm going to get a better setup for this. But anyway, like always, once we feel confident that we've got the backlash where we want and the timing marks line up like they ought to, then we call over the other guy and double check our work. And so Mark looked at it, Mark approves. So now I pull the idler gear back off and tighten down the bracket for the idler, and then I'll reassemble the idler gear on top of it with everything properly lubed and bolt on the retaining plate for that idler. Putting the gear cover on. Now from factory, those gear covers, they use like a button head Torx screw, and those are miserable to get out if they've been in there for a long time. So we just use a normal 5/16 bolt with a lock washer behind it, and it's a lot easier down the road when you got to work on stuff. Got all my injectors in there. I'm lubing up every contact point during the assembly, putting bridges on. There's the rocker assemblies, spacers for the Jakes to sit on, put our Jakes down. I don't know if I said anything earlier or not, but when I rebuilt the Jakes, but as I was doing that, I did find one Jake had a broken spring in it, and then several of the Jake's springs were actually compressed a good bit compared to the new springs that I installed. So, you know, it's overlooked often, but rebuilding your Jakes is it's worth doing every now and again. Everybody likes it when their Jakes work well. And so now doing the overhead, adjusting the intake and exhaust rockers, the Jake lash, and then the injector height. Intakes get adjusted to 15 thousandths, exhaust valve to 30 thousandths. The Jake gets adjusted to 33 thousandths. The book says 30, but don't do that. Increase it to 33 and they'll be more effective and you'll like it better. Even Caterpillar, they adjust them to 33 in the shop, even though the book says 30. I don't know that they ever came out and officially said do it to 33, but that's what everybody does. And then we got an injector height tool there. You put it around the spring of the injector, and it's got a little plunger with a indent on it, and you got to basically raise or lower the spring until you're in the medium of the plunger height. It's got like a high land and a low land, and you want it right in the middle. So you adjust half of the overhead, and then you turn the engine 180 degrees or 360 degrees till you're top dead on number 6, and adjust the other half. Now we're doing the riser for the valve cover and rockers and all, which also has the injector harness attached to it. So I'm attaching the harness to the injectors right now. You gotta be very careful not to over tighten those, because you can break the harness and cause shorts that give you headaches. And here's the oil cooler, taking it apart. Yeah, there's a couple springs in there, a couple seals. Usually those don't give you any problems. I just try and be thorough. I checked them, and one of those plugs was in really tight. When I popped it loose, it actually popped the housing, and I had to find another housing from a different, from my parts bin. And so that's why we started with a painted oil cooler housing, or oil filter base, I mean, and now we've got a dirty, ugly one. It's because the housing broke on me. So here I'm reassembling, lubing everything up, making sure the bores are clean and everything. If you've been around cats, if those O-rings haven't been changed out in a long time, you'll get corrosion build up in there and have, significant oil leaks is probably an understatement. You'll have huge oil leaks. So yeah, anytime you got the oil cooler off, take advantage of that and go ahead and clean all those O-ring surfaces and put new fresh O-rings in, because when those start leaking, you got a real mess on your hands. Got to make everything look pretty with some fresh paint. And there's our rear oil cooler manifold. We just lubricate those O-rings with some soapy water. Take a pry bar, push it into the oil cooler. There's our exhaust manifold going on. Got everything lubed with some high temp anti-seize. Now if you'll notice, I'm putting the studs and spacers on with the nut already on the stud. And that's not the way Cat says to do it. Cat says you put the stud in the head, torque it down to, I forget what, 26 foot-pounds or something like that, or maybe 22, I don't know. And then you put the manifold and spacer on and torque the nuts to 28 foot-pounds, I think. Something like that, or 34, I don't know. Anyway, you can't do that on this aftermarket head because they've got the bolt holes tapped too deep. If you run the stud in, then there's not enough length for the nut to go on. So you got to get that all metal locking nut threaded onto the stud far enough that it's fully engaged, and then run it into the head. Now, if you know how a stud works, that don't really bother me, I mean, you really shouldn't have to bottom out a stud into the body of whatever it's in, because that's not how a stud's supposed to work. The purpose of a stud is to stretch the threads and put tension on threads on both ends of the stud, and that's what holds it in place. So I'm not worried about that, but it's really frustrating if you torque all those studs in place, put your manifold on, and then find out that you got to take all the studs back out because they're not long enough. Just one of the things that definitely could be improved about this head. Here's our big giant air compressor. There's a couple O-ring seals there. You just got to work that adapter plate off, clean it up, and then get it back in. And the trick here is getting that adapter plate back onto the air compressor without that seal falling out of the groove. So just gotta be real careful and patient with that. And again, some fresh paint, so this looks pretty too. Because you know, all that fresh paint, well, that's what makes it run good, right? I'm not a machinist, but sometimes I play one on YouTube. So that bottom turbo mounts on this bracket here, and that bracket mounts on an adapter plate that we bolt to the side of the engine block. And that adapter plate's a 1/4 inch thick, so we got to take a 1/4 inch of material off of that bracket that holds the turbo. And so we got to bring it over the Bridgeport and fire that up. And what you see here that I just hot wired is the phase converter that I built to run my 3-phase Bridgeport. And the switches to turn that inverter on and off, they burn up. And so, you know, like a true small time busy guy, rather than find switches that are going to hold up after they burn up 2 or 3 times, I gave up, and now we just hot wire the inverter, and all in all, it saves me a bunch of time. So here you can see I'm just slowly, patiently taking a little bit off of this bracket at a time. This first pass was pretty light, but yeah, eventually I do take some deeper passes and just work my way down, taking measurements till we get to about a 1/4 inch, 1/4 inch of removal of material off of this bracket. I'm not very good or knowledgeable on a Bridgeport or lathe or anything, but it's enjoyable, and I really wish that I had time to do more of it and learn more about it. If anybody likes watching machine work being done, if you ever have seen this old Tony, or if more so if you haven't, you gotta check that guy's channel out on YouTube. The guy's hilarious, and he's a genius when it comes to machining, you know, and all the stuff that is involved in machine work. He's pretty entertaining to watch anyway. So here you can see it's taking a much deeper pass. I think getting towards the end of the removal. There we go. Here's that adapter plate that bolts to the block. And so we bolt our turbo bracket to the adapter first, using some more of those all metal locking nuts that we use on the turbo and on the exhaust manifold. Slide it all in there on some existing mounting holes on the block and lock tight and torque them all down. And so I think at this point, this is where we're going to wrap up for this video. We'll get this turbo hung up there, and after that, everybody be patient with me, and I'll release the next video in line. In the meantime, make sure you're subscribed so you see the next video, and thanks for watching.